gap between quality work and shoddy work is very, very small. If someone is good in an area, if you want someone average or shoddy, of course they will charge you just a little. Now that 5K you're saving gets you a shoddy work.
A structural engineer can be a consultant if he has acquired that knowledge and is trusted. It is not all about the age. That's what people mistake. Because it's all about what you know and what you have done on the ground.
It took me a while to understand and know that on the site, we not only have an engineer or an architect. In fact, 10 years ago, I knew that whoever is on the site is an engineer. I didn't know of an architect, a consultant, a contractor. Most of us, or many of us, that is a very big problem to us. We don't know who is an engineer, who is an architect, and what roles do they play on the site. Today, we are back again with the best duo for your site, our engineer and our architect. These people are very experienced. They have been in the industry for a decade now. And today we are back again so that they make us understand and learn who are the people who are primarily on the site and what are their roles on the site. We are back again with our engineer. I would like him to introduce himself.
Once again, my name is Timothy Simwe, an engineer by profession. I'm very glad and happy to be back on the Engineers Podcast and ready to deliver what I know about what is in the store for today. Just be willing to be part of the podcast till the end. Thank you so much.
So we are back again with our senior architect. He has done various projects. He has done schools, hospitals, hotels, and residentials. He's so experienced, and I would like him to introduce himself.
Hello everyone, I'm Akankwasa Herman. I'm happy to be back on the panel. We have a great experience to share today, and with the skills we have both in architecture, interior design, landscaping, and project construction, I'm very happy to share what I have today.
Yes, so the biggest problem I faced when I was so young, I don't know if it was age or when I was ignorant about construction, was I couldn't differentiate between an architect and an engineer. For me, whoever I could see on site was an engineer. But later on, I came to realize and understand that there's a very big difference between an architect, a consultant, an engineer, and a contractor. And I would like you to tell us and teach us what is the role of an engineer? For example, a civil engineer on a site. What does he do?
Basically, the role of an engineer on a site. So engineering is wide based on the entry you participate in a project or in the process.
Yes.
For example, you can start at a high level when you're a consultant. It means that at that level, you're either heading the design team, you're one of the structural engineers who are dealing with the structures. These are bars, the analysis of how the structure will be stable when executed. That is the high end of the entry where you are the consultant of the project. Still, you are an engineer of the site. Then you come on execution. There's what we call a project engineer. Someone who oversees the execution of the project which has been designed by the consultant.
Yes.
So at that entry, it means that the consultant might not be on the ground. The drawings have been delivered to the contractor, which contractor has got a project engineer. So he's also an engineer now at that level.
Yes.
But his work is to ensure that the project is executed as it is from the consultant. Then under him, the project engineer, he could have what we call the clerk of works. Sometimes he can also be an engineer, especially on big projects, who oversees every activity, takes daily activities there, the schedules and everything on ground, then hands them over to the project engineer, who is usually there either representing a contractor or a client based on the approach they have used for the execution of the project. So he's still an engineer, but this time employed as a clerk of works. So the role of an engineer on a site is broad based on what position you're occupying or what is the entry for you on that project. And it reduces or changes with the size of the project, the contract terms, and what the client wants. If it is the government, an NGO, there's some projects they need a registered consultant to be the head of the team who does the design and heads that design team. Then under him, he must have a project engineer. Some projects need him also registered. Even if he's not registered, he must have at least a bachelor's degree in a recognized university. Then you find sometimes they've got a clerk of works. Either they want a graduate or they want a diploma holder in civil and building. So you find that engineering moves. Even sometimes you find others go down and you find they are foremans. Even a foreman can be an engineer in that position. The foreman leads gangs on ground. Like he leads people are mixing concrete, people are mixing who are doing brick walling, He can also be an engineer who is actually qualified as a civil engineer or a diploma holder. So it works to that level. So still you are an engineer. I'm talking to specifically to civil engineering on site. Much as the other engineers, the electrical engineer is also under engineering.
Yes.
Then we have mechanical engineer is also under engineering. Those ones, they deal with electrical. Then the mechanical, he handles plumbing works. He handles drainage works of the entire site. He's also under engineering as part of construction team.
Engineer Herman. Yes, I know I've confused you. Because for a reason.
You don't appreciate an engineer and an architect.
Yes. So most of us call architects engineers. Yes, and it's a very, very big problem to most of us. We don't know. We can't differentiate the two of you. So, Herman, I would like you to briefly explain to us what is the role of an architect and who is an architect on a site.
Yeah, the role of an architect, it is a bit broad on a site because it is. Let me define it two-way because projects are different. There are some projects that are big and there are some that are a bit small. But to really understand the role of an architect on a project, I'm going to first define it on a bigger scale project that has consultants. Mainly an architect carries many positions on a site, but focusing on where like a project has a consultant, an architect can design a project, is the main design of a project. Some of them can come in as consultants and there's a structure. So an architect stands in a position of like leadership on a site. Besides designing, besides creating this project, because we have a project architect, then we have a consultant. So those positions can also be taken by an architect. So where an architect is a consultant, is going to supervise the project, is going to oversee, is going to check the cost, is going to check the quality, is overseeing every team in a place of leadership. Then there's a project architect. Now, a project architect, you've designed this project, and on site, you're also leading your team. And you have a team that has project managers, you have structure engineers, you have electrical engineers, you have cost engineers, the quantity surveyors. So all of these, they are a team that you're leading. And maybe if there is a consultant, there's a consultant that also checks you. You get it? So it is like a structure that is checked. Most of the time, it is always comfortable for, if someone is the project architect, it is comfortable for organizations to select another architect to come in as a consultant. Because now, if I'm the project architect and on a big projects, if you make me a consultant, maybe there are things I will not show you. So to show that transparency, you may need to bring in an entity that will check me. You get it? So, but there are very many roles architects play on the site, and mainly is in quality control, making sure what they have designed is what is implemented. Then they even channel into managing costs. How do we save? How do we that the site comes with a lot of challenges and changes, modifications, provisions of detailing every instruction that is needed on site. So when construction starts, there are elements that are not captured on files that people submit to the council maybe. So when you have an architect on ground, they detail everything. By detailing, it's like expanding on a large scale a drawing, expanding it to a large scale to the point that you see each detail of what thickness, what measurement, what quantity, all of that. So there's a big role architects do on site.
Wow. So before we go further, because now we've seen the roles of an architect, an engineer on a site. Now I would want to know, if I'm having a dream of building a house, where should I go first? Should I go to an architect? Should I go to an engineer?
Maybe to answer you on that, when you have a dream to construct, you have to first go to the architect. Why? Architects are not people who just design nice things and what. Okay, to be open on this, architects are not even designers. What we do, we translate your dream.
Yes.
You will come and tell me your things, and me visually I'm starting to develop it. So we just translate. We are translators of dreams. Dream of something, dream of a house in shape of an egg. Me, I will find ways to put it there. You get it? Dream of a house that is floating somewhere. I'll have means of putting it there. So the more an architect gets more skill to enter into someone's mind and translate their dream, the more they become a good architect. Actually, a good architect is one who can easily translate someone's vision and dream. It's not someone who can design very nice things. It is not that way. Though people may think, this is a nice design, this is a good architect. No, it's not that way. If you come and tell me what you want and I translate it perfectly, just know I'll be the best architect for you. So we just translate. So when you have an idea of constructing, you have this dream. When you go to the architect, they translate that and then they put it on paper. Then the journey starts from there. We invite in a structural engineer to check and see this dream, how is it standing? How is the structure going to stand on the ground? What bars are they going to use? Like now they start sizing the system that holds the building. They are the mechanical, electrical engineer come in, the cost engineers come in, the surveyors come in. So the journey is like that. So it would be easier for you if you first go to the architect, your dream can really be translated and put on paper.
Meaning that if I have an architect, I can build my house. I don't need a civil engineer. In simple terms, where does a civil engineer come in? Because we've seen that from the architect who has given us our dream, or who has put our dream on paper. Now, where does the civil engineer come in?
Well, the civil engineer comes in immediately. Okay, the design when it is out, when after we are done doing the concept and you've loved it, that's when I push it to other teams at that stage. Once you're happy with your designing, that's when I invite in a civil engineer. But for us, the way we work, the way we collaborate right now is that I love to involve the civil engineer even at the stage when I'm designing.
Why?
The reason is this. So design is a bit flexible. Design is different. There is no project I design and it looks the same. meaning that I just look at translating someone's mind. So we can never think the same way. So when I'm doing that, there are elements that I need to have a discussion with a structural engineer during the time of design. For example, when I get a client and their dream is to have a very big living room, a lounge with 10-seater sofa set, 15-seater, that means I have spans. So at that stage when I'm designing, I'll do my 7-8 meter span, but inviting a structural engineer to collaborate in that, to help and understand, if I span this way, will the structure stand? Will it work out? What do I really need? Because they have a good skill and knowledge to understand that if they calculate the loads and forces, they can really support this. I think engineer can even add something on that.
So also to add on what he has said, I think one of the problems clients get is the entry point to construction. Like most clients whom I've seen, he finds a builder and asks him, I want such a dream. He doesn't differentiate a builder, an engineer, and an architect. Starting from a builder, like anyone can build. Someone can start and get experience, lay bricks. Now, anyone who is constructing, in a layman's language, is an engineer. Engineer. So someone you're driving, you see some house, you find someone there, you say, engineer, this is a good house. Maybe someone's doing a finish. Even a person doing finishes is called an engineer on the side, because that is what the client believes that person is. But most of the time, if you want like a house, if you can do that, you ask that engineer, I've liked the house, or I have got a vision, I picked my house online, but who is your architect? Who is your designer? Simplify it. Who designs for you? What do you do? A person who designs is the architect. Now, in the design team, that's where we find the structural engineer. Because also structural engineer, it is a specialty in engineering.
Yes. Now you're confusing us.
Yes.
Who is a civil engineer? Who is a structural engineer? Who is an architect?
That is a good thing.
Yes.
I did civil engineering, and at the university level, it is wide. When we are studying civil engineering, we start when we are doing all courses, but as we go to year 3, there are branches that come in civil engineering course, because I was at Chambogo University. So we have what we call structures. If you specialize in design of structures and it becomes so good, especially in year 3, then you can be a structural engineer. Not necessarily that you have done structural engineering, you can do it at masters, but you start from year 3 becoming good at structural engineering. Like me, at year 3, I was good at designing structures. Then there are people who separate and they go to water engineering. They become water engineers. Someone's so good on water engineering that he can't even design a toilet. I've seen my friends of that caliber. He specialized in sanitation. He's good at that. He's at Rubiji doing all that. Someone can go and do road engineering. He's also a civil engineer, generally, but specializing in roads engineering. He's good at roads. He sets those curves, all that. Like me, I cannot even set a road, but I'm a civil engineer, generally, but I specialize in structures. So there is now someone who does railway engineering. He's still a civil engineer. We studied it. It can take me some time, and I read books, and I can be back at that. But I'm still a civil engineering. Then we come in year 4, we do airport engineering. Those airports are done by civil engineers. Then there's what you call military engineering. When you go to military, there's a type of engineering they do, building banks, tunnels, all that. Then we have those people who go deep and maybe on roads, he specializes in bridges. He becomes a bridges engineer. So they are all civil engineers, but the specialty is different. There are those people who finish the university and you find they are into construction. Most of them are doing project engineering, they're doing what? Most of them, they're also called engineers. But he can't design structures, but he can execute a project. He's also a civil engineer. So on design part, when you're still on design level, and you need the structures, you look for a structural engineer. He's a civil engineer specializing in structures.
Yes.
You know, that is the person you need. If you have a road and you want an engineer, you look a civil engineer but specializing in roads. If you invite me for work for a road, I can't. Because for the last 10 years I've been doing work, I've been doing it in structures. But I can design even a 20-story structure. That is okay for me. But I cannot design a small road because I've not specialized there. But my friends have done that and they're into roads. So basically that's the difference of a structural engineer.
Okay.
Yes. So if you're asking, you have to know which person am I asking. Is he a structural engineer or a project engineer who does construction, or is a roads engineer? But we are all civil engineers and we were in the same class, but we specialize differently.
Okay. So now on our plan, we are having an engineer who is a structural engineer.
Yes.
Okay.
He does the structures. But you still can get a civil engineer who's not a structural engineer, but executes the project.
Now I'm getting confused because I'm asking, what do you mean by structures?
This is the design of the stability of the structure, especially for high-rise buildings. So long as it starts from ground and fast, and not a residential, ground and fast. You need someone who designs the bars. I can say bars, the bases, how the structure will be stable. He does the frame. The architect does the beauty. He puts all those 3Ds, the use of space and everything. But the person who does the frame, who does the structures, he is called a structural engineer.
Yes.
You can meet an engineer, a civil engineer, who cannot design the structures of that project, but he can read the structures and implement it. He's still a civil engineer, but he specialized in building. Now, he's what we sometimes refer to a contractor. Much as in Uganda and according to our laws, anyone can be a contractor. As long as you have money and you can execute a project, you can hire an engineer. He helps you in execution of the project. So if we are designing the stability of the structure, that is a civil engineer we are talking about who mastered structures. So in specialty, he calls himself a structural engineer. If I want to specialize, maybe you're doing your masters, some people do it in structure. And it is there in different universities. But now the other civil engineer who does the execution of the project, they prefer a master's in management. Wow. That's the difference. Because he is into management, I'm into design. So if I'm mastering, I have to master in my specialty. So that is how you can differentiate that mix-up of engineering.
Wow. For me, I thought that when you're going to build, you just get your bars, just getting that pattern. Yes. That's what I thought. But now we are getting to understand and to know that before you build or before you start constructing, you need a structural engineer who's going to balance the loads on your building.
Yes.
Is the one who's supposed to ensure. Are you the one who ensures the strength of the building?
Yes.
Yes. So, and it's a very big problem, by the way, whereby we are seeing most sites failing or falling because of, should we say because of lack of an engineer, a civil engineer on site, or maybe some other reasons?
It starts with I think deficiency in the design team. That's the general word I can use. It starts with an architect, an engineer. Most clients want to think they know, and he starts designing things that cannot be implemented. You know, when you get money, what I've seen with most clients, they feel like they don't need professions. Like, I know if I can get my money, why do I need these people? Why are they paid even on the project? Why can't I buy cement? The man I'm going to pay you for consultancy. So they prefer buying cement than having someone to help them stabilize their structure. They help me around. These boys, I'll pay them over weekend, even they can make their own schedules. But they forget that there's always design a span of 8 meters, like you said, by 8. It is different from a span if it is 6 or 12, if a cantilever is a bit wide. So now, the deficiency in the design team of the client actually can lead to the collapse of the structure. That's what is common when you see anything going down. Actually, there's an engineer I've not talked about, that is a geotechnical engineer. He deals with the soils. So now that is now a person we first look for. If they did the soil testing, what were the conditions there? What did he recommend in excavation? So that we get to know what were the causes. But usually the general cause of structures failing, it is deficiency in the design team. Meaning either the structural engineer was not experienced, or the client didn't involve right people, or there was a problem in the execution. So there are so many causes. That's why it is usually general, even if they are making an assessment to know the general cause.
Ackerman,
Yes.
if I'm going to build my house,
Yes.
since that we say that we agree that we first go to the architect. Now, on execution, when I'm going to start building
Yes.
my house,
Yes.
we are done with the design.
Yes.
What should be done in that process, in preparation to start the construction, to start the building on site? What is that process that you go through from the design to project handover?
Okay.
Yes, to handing over the project to the client.
When you've done the designs, like I said, we've translated your design, you have handed it over to other teams you are collaborating with, and they have done all their work. Then after the teams have done their work, it is important to calculate the cost of what they have designed. Because if you don't, you might be overwhelmed. You may be in love with this big, nice design, but when the cost is different. So normally me, what I tell my clients, I involve them, I involve the entire team at design level, so that when we are making these adjustments, it's better to make adjustments at design level. So the easy plan would be, after you've had your drawings done, all of them that are required by the law, then do the costing. When you do the costing, it helps you to project, to know how much this would cost. After doing the costing, it even helps you to plan. You get to know how you are going to construct this. Then after the costing is done, then this is where now what we have been talking about comes. These guys on site with their roles, you start involving that team. Have an architect on site. Why? This person knows what you want. They exactly know, they have translated your dream and they understand part of what you want. So it is important to have them on site, because they would help you even supervise. They would help you take the burden of, that risk. Some clients want to supervise for themselves, but there are things a layman can't see that the professionals can see on site. So this entire team we are talking about, involve it on your site. It doesn't take much. You see, the gap between good work and poorly done work is very small. The cost, the margin is very, very small. But people look at it as they want to save. That 100K you want to save may cost you more in maintenance. You get it? That's even us when we are collecting our team on people who are skilled. We normally go with the high performing people. Why? There is a product we are putting out there. We drill on quality. So if you have this team on site, we do the checks. By the way, construction wouldn't be very complicated, mainly in sub-Saharan Africa, mainly in Uganda here. But there has been a lot of impersonation. There has been a lot of defining who does what and who does what. So that brings a challenge whereby, for example, if I got a mansion who is very good at being a mansion, then clients normally, if someone is good at doing masonry, building walls in brick and mortar, for them they think this person knows everything. Before you know it, they give the person plastering. Before you know it, is the one tiling. Before you know it, is the one. And these people fail. This person will fail you because their special package is mainly in bricklaying. And it is us, the team, who will know. Because if you're plastering and you have an architect supervising, you have a structural engineer there, we know that, okay, now this one is going off the dream of the client, and they will align. So once you've prepared the team, the design team, then you involve it in construction, and you have the costs, you know the budget. If you're good with the budget, or you can manage it, or you have a way to manage it, then you're good to go. Because, okay, there are some other things we have not talked about that have to be done,
Like
even
what?
way before.
For example, I would ask a question whereby I've seen very many engineers before they build or before they design any building, the first thing they ask for is a site visit. What is the reason why an engineer must first see, or an architect must first go and visit the site where the building is going to be constructed?
Well, I normally tell people that one of the most important things to do if you're serious to start is a site visit, because this is a place where you're going to construct, and there's a lot we pick from site. Now let me just shed a few. An architect can pick on site. When I go on a site as an architect, one, I'll pick your boundaries to get to know the size. Now, knowing the size helps me to arrange your space. After knowing the size, I'll know the nature of the site. Is it sloping? Is it like the sites have different characteristics around them? Is the site in a place where there's a lot of noise? Does it have a bit of vibrations? Does it have, does it have a lot of winds? So all of these things, I use them while designing. Then another thing, I need to understand the orientation of the sun. Now these days it is very hot. People are in their houses burning because their architects, maybe if they were not there, they didn't think about it. But their houses, you go in right now and you will not even know that it is very hot because they were planned well. The person came to site, understood the solar system, how it works, how our sun moves, what time is it very hot, where should I place a bedroom, where should I place a living room, like zoning those places. We determine that on site. Then another thing I would say, like the views. When you're on your site, where best can you enjoy those views? You get it? You don't want to build your building facing a side that is boring. So there are those features around the site. Then another thing we pick is the breeze, the air. Because we design with we put in cross ventilation, whereby you don't need AC in your residential. You get it can be for the offices and what, but your residents take advantage of the breeze and you come up with that. So there's a lot we pick on site, and when someone goes to site, it is easier to design something that is even cost effective. It is very easy because you can get solutions from site rather than designing, let me call it designing in air. You've not taken me to site and you've just told me, you know what, I'm planning to build a house in the future, a 5-bedroomed house. So I have no idea where the road is, where the access will be, where the main entrance will be, where the water is, where, like all of that. I'll be just doing something in thin air and just put it there. And maybe you can take it to a site and it won't fit. Maybe it won't relate. Maybe it will not. Even if it fits, maybe it would work out funny. So it is very important to take that team on site. The same applies to structural engineers. You involve them, you go with them on site. Now they also have their part they pick when they go to sites.
Wow. So for me, I thought that maybe it is just something that people do for formality, just because he's an engineer. I just want him to go and see my place. Maybe. Now, from the design, which step do we go to next?
So basically, after you have got a designer who is maybe an architect, to add on what he has said, I would think a client should move with the designer who is your architect. You go to site, pick all the parameters you want. From there, he starts executing your dream on paper. He brings it on paper, what you want. Then from there, usually architects have engineers they work with, or the structure engineers, if it is a storage structure. If it is not a storage structure, like a 3-bedroomed house, 4, 5, from there he satisfies the work, print out the blueprints, then you submit for submission so that you have approved plans. But if it is a storage structure, like currently, you have to now have a geotechnical investigation. It's where now you send another person on site. That's a geotechnical engineer now. Sometimes they're done by labs. We have very many in Uganda. Even here at ArcBuild, we do geotechnical investigations because we have got a department for lab works. So we check the soils, do the analysis and everything. We know that these soils can carry the structure. So the geotechnical engineer makes a report and submits it to a structural engineer. Then the structural engineer does structure analysis of the structure, ensures all the bars, does the report, does the drawings to make sure that your structure is very fine. So that's the work of the structural engineer. He just puts a framework in the design of the architect. For us structural engineers, we don't know anything about space, air, that is none of our business. Can the building stand? Yes. That's what we focus on. Then when we are done with that, then we take the drawing to the mechanical engineer and electrical engineer. The mechanical engineer puts in drainage, the toilets and everything. Nowadays, they want also drawings for that. Then the electrical puts in the electrical appliances, the piping and everything. Also, that is now the scope of what is required. Then from there, you have a full set. Actually, when you go to the site, the other person you have to send, who goes usually the architect, is a surveyor. Because you have to open boundaries, you know whether the stones are there. If it is a KCCA project, you have to carry out a search to know whether what the title you have exists in the land system. Then you have all those documents. Now you have a full booklet of drawings only. You have an architect, you have got a survey report, you have got the structural engineer's report and drawings, the mechanical drawings, then electrical drawings. Now, when you are designing, because usually you must be working hand in hand with a quantity surveyor. We have a land surveyor and a quantity surveyor. Those are two different people. A quantity surveyor is going to be giving you estimates or the cost of the project. We don't want you to design a project to the end and you find you can't afford it. You have put in a lot of money. I believe that when you start the project with an architect, one of the things you should always ask the architect, so that you don't go full scope. I've seen that. It is the worst. You have paid all the people, but you can't afford the project. You have to go back to zero and people give up. At that point, so I would think that the architect should help you with his quantity surveyor as he's designing, or you should give an architect the budget range of what you expect. You say, I have maybe 200 million or 100 million. What can you design for me that fits there? So that he has a scale where he stops, instead of just designing openly. So now, by the time you finish the entire project, a serious client expected to be having bills of quantities. When you are sure that what you are going to execute is going to really be easy for you. Then that set of drawings is what you submit to the council so that it is approved. By the time it is approved, now you have got a satisfied dream, which even the government is aware. You pay taxes to the council, then you are ready to execute. That's where you look for a contractor or a civil engineer who does construction, or your boys you think can execute the project if you don't want to involve the consultants, or you take the direction the architect has the advice does. you bring back the other team to come and be helping you and supervising to ensure your dream comes true. So that is, I think, the summary of what goes through in design to have something and you execute it.
Yes. On execution, I remember one time, engineer, you had gone to some site and I saw you busy quarreling with someone on site over the depth of the foundation. The issue was, I remember the issue was, you wanted him to make it a bit deeper, but he had made something that was a bit shallow. What could be the reason why you did that?
Basically, this is what I've been telling clients. The goal of a contractor is to make a profit. Like, if I'm a contractor, much as I want your dream, but I also like business. I'm fighting with business because doesn't make sense to me to bid for your dream and I make losses. So meaning that what's in the head of the contractor is how can I finish this project very fast and I start another one. That's why most of the times contractors divert from drawings. I had a reason why I'd put excavation depth not less than 1.8, but this contractor just puts it at 1.2 above the ground. Because in my design, I was seeing that the structure would overturn with the wind loading that is side. So when I reached on ground, I found the contractor is just excavating to 1.2. And when you talk to them, as when you are special on the side of consultancy, they think that we don't like them or we want their business. But much as for us, when we are hired as consultants on the side of the client, we are presenting the client where he doesn't understand what is being done.
Normally, we know
like we've had that, you know. But this is my profession. I don't care. I have to do what's right. If I've designed, the foundation must be 1.5 or 1.6 or 1.8 below the ground. I've done the technical investigation. There's a lot of conclusions I've come to treat that. Because the depth of the structure is based on the height of the structure. Because we fear either to have deficiency settlement, you find the structure is moving sideways or what. And we do it in design and determining the foundations. So that's why I was a bit tough on the contractor, because he thought that what he thinks is what's right at that time. But what we had designed and what we had tried to execute, sometimes even they like clients that it's the cheaper way to do it. When things backfire, they run away and they leave problems to us consultants. That's why we are a bit strict when you're executing our projects and make sure that what is on paper should be done on the ground, because already we have done due diligence before design.
Yes, so this goes to everyone, that when you're building or when you're starting to construct, not every depth, not every building you build has the same depth as the other one in the foundation. Let me repeat it in Luganda. Enyumba gyozimba teyenkana omusingi gwayo tegwenkana nkano gwenyumba endala. To avoid issues like falling buildings, I've heard of a term deflection. I don't know what is meant by deflection.
Deflection, especially in the beams. You know, most of the times when we are designing, I've been on the site I've been on previously. You know, our clients are very, very inquisitive. Like, they ask a lot of good things, and I don't blame them. It's what they want. This client wanted an 8x8 sitting room, 8 meters span, no beam, nothing. So now I reach on the site, I told the client that if you want that beam, as a consultant, I would design it, but it involves a cost. Say which cost? I tell him, you must use a solid slab, but we are going to have some distribution bars of big bars of around T20 and T25. They are the most expensive bars on the market. For him, he calls a friend and he's like, see, this engineer has told me I have to buy these big trees and what? They are costly. What can I do? Can't I use max spans? So I told this client, if you're going to use max span, it's very okay. I want you to come and sign that you are taking liability of the structure. If anything happens, I'm not liable. And the letter you write, I'm going to give a copy to the council. And this is where the client is like, no, but you're the designer. Let's do whatever you want. Now, in my design analysis, if you're going to achieve that wide sitting room of 8 by 8, a max span distribution slab would not work. Why? Because in our design, it distributes loads in one direction. Actually, we call it a one-way slab. And when I designed, it was deflecting. So the slab was going to sag in the middle if he insisted on doing it. And for me to be protective or to make sure I withdraw from the site, I told him to come and write an instruction as a client that we follow what his friend said. But later he's like, let me follow what my engineer said. And we did a solid slab, which didn't deflect, and the structure is standing. So basically that's what happens when we say there's deflection. The structure sags downwards at points where it fails to carry the loading that it has. And there are conditions which usually happen in sites when there's especially no supervision.
Yes, I think you've gotten that. Not every situation has the same solution. So most of us have that problem whereby we are carrying the other information from the other way because the other people did it the other way and we also want to do it that way. It is a very big problem, and it's a no-go for anyone who's building a standard building. Yes. So you need this team. You need an engineer on your site so as to solve those problems on the site. I think the major role of a structural engineer on the site is to sort the different problems first in the structure as they're building the structure of the project. For example, let me say, in case we are having let me say, the way we've talked of a span, whereby we're having a long span. So it is the role of the structural engineer to tell you what should be done.
Yes.
Not your friend to tell you that
Well, that's very true.
Yes.
Actually, I told this client that you can't be two things. You can't be a doctor and again you be a sick person. Now the doctor has recommended the surgery and you say, but I read it on YouTube. You choose one. You either be a client or you be an engineer. Because I was telling him your house actually was going to deflect. But when we did what is right, I even invited him with the family and all people. I said, you can come and dance from top and see if there's anything that happens or if you can see any vibration. And the house is turning, it has no issues. Because we design and we have been doing this and we have got experience and I know where failure can come in a structure, even under construction. So that's what we help in supervision when we are maybe invited to be part of that team.
One time I faced a challenge whereby I went and bought cement for someone. But I was so ignorant. I didn't know, I thought that when you get cement, when it is maybe in that bag, it is sealed, what, it is standard. So for me, that's what I thought. So I went somewhere because I wanted some profit. So I got some guy who was selling cement that was a bit cheap. Now, on taking it to the site, we reached on the site. Now, this guy tells me, you know what? Before we take that cement in the store, we have to first weigh the cement. My God, what happened? What happened? I was like, it's okay, you can check. I was so comfortable with the product that I had. So, on weighing the bag of cement was 48 kilograms. I thought that maybe it was a standard. Maybe, when they are packing cement, it is 48, not 50. And the guy was like, yo, cement wo muze yo. The simwa agala. A bag of cement is 50 kilograms, right? And now for you, you've brought 48 kilograms. And I faced a very big problem. Now I have the cement. I've gotten it from the other supplier. When I told him that, you know what, I'm bringing back the cement, he was like, goods once sold, they're not returnable. You can't return it. So I was stuck with my cement. And later on, this guy was like, okay, it's okay. You didn't know. It's an area you've made. let's take the cement. But on taking the cement, he was like, we have to also first check the cement. Is it exactly the cement that we needed? Because he was like, sometimes they add in other impurities in the cement. Now, on a site that is starting, how do you ensure that you are getting the exact materials that are required? For example, also the bars, because we find that someone says, you can use that bar. It also works. But you as a structural engineer, as an architect, what do you recommend for the client?
For like what you've talked about, once after we have done with the costing and what, now we are into procurement. Now on site, there's a procurement system that has to be there. That has to be very transparent. You'll meet this. It is not only in cement. It is not. I know Ugandans with saving. Every person who is on site, they come to work and save something. So you should have that. So we have seen this. You order for a truck of blocks. You've ordered maybe for 10,000 or 1,000 blocks. Someone brings you 700. You get it? Very common. You order these poles they use for scaffolding, the kalitusi. You've ordered maybe 300. Someone brings like 240. So with a good system, you really help like to control quality. So you make sure that's the importance of having this team on your side, because for us we have checks we would make. We know the system, the procurement system, how it moves. We have an understanding of the market prices, and we understand what is good to be used. You get it? So when you have the structural engineers, you have this team you have been talking about on site. Like when something is brought on site, there are checks that are made. Some checks are visual. You can look at a brick and know, this one, Kavolam. You can just look at it. You can open cement and look at it and say, you can look at the pack of cement and you know that this is counterfeit. Yet, maybe a client won't know, maybe they are constructing for the first time. Maybe they have never bought cement in their life. It is the first time they are buying these bars. They don't know what T16 is, what R8 is, what a BRC is. They are hearing these things for the first time. You get it? Like you may even start asking, what is BRC? What is that? There are people who are hearing them for the first time.
Yes, that's true.
You can easily be duped. Like they'll bring you fake stuff. Like I remember there's a project we were on with engineer. We had recommended drinks, very good drinks, and then the client procured, I think, over some rings. I will not talk of the company where they came from, but the rings they used, we had recommended ribbed rings in the structural design. So they brought rings that they are round, those smooth rings, they were colloded, they were not good. So as a team that was on site, we had to push the client to say, no, your rings won't work out. The client brought in some friction. You know, you guys have already put man and what? We put it in writing. Like he has said, on our side, if you refuse, we just tell you this won't pass. There's this thing I know about concrete, that concrete is very funny. That it has properties. It has a way you have to do it. So even if you have the right cement, you have the right sand, you have the right water, and then your bars are wrong, concrete won't work. It is like that. These elements work all together. So in determining quality, once you have a good team, and even if they are not there, like even in procurement, at least inquire from them. If I'm buying bars, who is supplying the best bar? If I'm procuring maybe things to do my steel works, who is the best supplier for this? It would help you not to mess up. And knowing a supplier, that means I know the cost. I know how much it would cost. So to avoid all of that, to avoid all the things that affect quality during procurement, make sure those people bring those samples, and when they bring the samples, when they are delivering what you've procured, someone is on site to check the quality. That's why on sites we have a clerk of works. Now the role of a clerk of works, they are always on site daily. They are also skilled personnel. They can all be structural engineers. Okay, they can be engineers, they can be architects, but it is a person who has the knowledge of construction. So these ones represent the client on site in the absence of a consultant, in the absence of maybe the main architect, in the absence of the main engineer. The clerk of works has to be there. They even do daily reports. They have delivered this quantity, they have delivered this, it was delivered here. That kind of structure. So it would help a client to have someone who is checking quality. You brought the cement, let us weigh. That gentleman who asked you to weigh cement, if he was not there, they're going to use it. During that, it is, things are moving on very fast. You could miss out on something and it could affect the quality of what you're doing. So it is important to have a system on site that checks you in that time. Even clients can make bad choices in the market. A client can go and be convinced, you know what, now that cement you're asking for is maybe 34. There's this one of 28, there's this one of 31. They bring a quality, the engineers maybe recommended to use that cement of same 2. Then this one brings some cement that is maybe meant to be used in something else.
That's true. Wow. So for whoever is looking for construction materials, please check on www.akbuildug.com. You'll get the best quality of materials. Don't be like me then, where I got the worst. So from there I learned, and now we are having trusted suppliers of cement. We get it directly from the companies, so we are distributors of these companies, cement and steel. Yes, but is it a role of an engineer to direct? Should I call it directing or helping the client on which material he should use on their site? For example, the bars. Because I know for us, when we are building a residential house, these normal residentials, we buy our bars, the usual bars, because yes, also in bars we have different qualities of bars. Is it the engineer who helps the client on which bars to use, on selecting the material to use, on bars? Akam and talked of cement. We've been having a very big problem with people says, nze cement kasawo kamu katabuze gali 7-8. Not knowing which type of cement, because I know also in cement we are having different types of cement. We have SEM 1, we have SEM 2, SEM 4. Now this person you find is using kasawo kamu on 8 on 8 gali, and is using SEM 4.
That's true.
Yes. So engineer, take us through that process of selecting which materials to be used on a site, and also the proportions to be used.
So basically, when we are doing design, me as a structural engineer who has been into consultancy for some time, we have standards we follow. Nowadays, we use Eurocode in design, and we have a given standard. If you want to have a certain strength, what you're supposed to follow. I can give you an example. if I'm making a design of a structure, and in my design of analysis, I use a high yield bar of strength 500. Let's say the kilonewton per meter squared, yeah? Meaning that if I go to your site, and this is what I used in my report, and this is what I recommended in the drawings, the strength of that bar must be 500 kilonewtons per millimeter squared. Now, sometimes ago, when we used not have those we can call them bars which have rings, ribbed bars.
Yes.
We used to reduce even the design which is recommended. We make 460 because the bar which does not reach that strength is not going to achieve the strength I want, which I put in design. That's why sometimes you are strict on the material to use. I can now tell you that this element, which is a structural element that is going to carry the roads from here, must be casted in class 25. Class 25 is a mixture of concrete, cement, and sand. But the strength of that component after drying or after curing, which is usually 28 days, should be 25. So now, there is a cement that will help you achieve that. There is a ratio that is recommended that will help you to achieve that, which we usually provide in drawings, you know. So most of the times, clients or even executors do not have knowledge about that, you know. Because you go to the site, you find someone building, you ask him, what is class 25? The guy can't tell you the ratio of class 25. Even the client doesn't know, even the person building doesn't know, but on the drawings, it is there. So that is one detachment we get between execution and the reality. So you find that someone is doing things based on his experience. That's why some structures just fall, especially if they are wide and you do those terrible errors. For small ones, sometimes they survive. You find a residential house having a crack. You imagine how can a residential house carrying just a roof crack? I asked, did it also need an engineer to do analysis of a brick? Why? The client chose to use clear bricks. He didn't know that if you use a clear brick and you maybe expose it to water, the soil bricks, these normal soil bricks, you put it in the bathroom and you pour water every day, later it becomes weak and the roof load comes and the wall starts cracking. Oh, this client did not know that if you are using a header bond, it becomes a reinforced wall, other than if you are using a stretcher bond. Yet when you use a stretcher bond, you organize your bricks in this direction, the number of bricks reduce. During construction, you feel ease, but structurally, your house is not heavy. I've seen someone does a house and the walls are shaking, but it's a residential house. You're like, how come your walls are shaking before the roof? And the engineer tells the client, it will be stable only with plaster. So there's that still some deficiency in knowledge between the executors, because most people have got the experience, they have learned on site, but they have not got the technicality of doing what we call standards in execution of a project. You know. So then on materials, there's a lot in materials. Where is this material used and for? And what is the source? And what's the recommended strength for that material from the manufacturer? You know, there's something clients don't know, that I can go to any company and I order a 40 kilogram bag of cement and they'll pack it. For them, they want business. It is common with iron sheets. There's no limited length of an iron sheet.
They don't have a standard
They
size.
don't have a standard length. So I was on one of the hardwares and this guy was selling a lot of iron sheets. And people were wondering, this guy, his are cheap. The guy had made an order of 2.5 meter iron sheets. But the most common ones in the market were 3 meters.
Yes.
So it was 500 less in length, hence less in price. I kind of like, ogenda oli, but yerimu na yako ya kubein samu. So even bars, you can go and order a 10-meter bar. The factory has got a lot. It is a long bar. They usually pick what you want. So you see, this guy has very cheap bars, and you ask yourself, how does he do it? This guy has got the cheapest. But ask the length. Instead of having a 12-meter bar, which is standard, for him he told them, remove 200 because my beams are already set on ground. And when he brought them, he put them on the hardware. So he's cheap by that removal of 200. And that's why in the factories, they don't measure bars in length. They measure them in kilograms.
Yes.
How many kilograms are you taking? Why? Any length you want, they will give you. So it will be up to you. So we have to have knowledge, which I usually refer to as material science, when you're executing the project. The more knowledge you get on that, that's why I can do a project of 500 million to the client, and I use my material science, I do it at 300 million because I know what to be done, what ratio to do, which company has got standard bars. Then I avoid brokers. I make sure that I have got source of material which is okay. Then I save a project that is mine. Then the client tries it out because of those errors and what he find has spent out of money, especially in materials, and you find they are crying that building is very expensive. So you have to have a little good knowledge on the material science and standardization for you to execute a project and come out well.
Wow. So that is the importance of an engineer on your side. So most of you thought that maybe when you're starting, you know your hardware, where you get your materials, or you know the sources where the materials are gotten from. But what you didn't know is that also in the materials, we have qualities.
Yes.
You have different grades of materials. Someone asked me a question somewhere and was like, "Nemutuleke namwe. Ne material na ya inamu kirasi." Not knowing that SEM 4 is different from SEM 1. And its recommendations are quite different. So, Ackerman, we've started building our house.
Yes.
Or our project.
Yeah.
Now, how do you ensure that the dream or what you put on paper is what is being done on ground?
Yes.
Now, when you're constructing, construction has stages. So those stages, they need to be taken account of. So one of the main ways you can ensure what is on paper is what is on ground. Like I've said, you have a team that is on site. This team has done all of that. One of the challenges I've seen mostly with the clients, you've started building in this place, maybe developments are coming up a bit away from town. So you go in this area, then you look for omzimbi wao, like you get it. And now this person, because they have been building from there, they don't know the new techniques, they don't know what is being done, and now you've brought them a plan. Some of them don't even know how to interpret it. You get it? Because they want the job. They won't tell you that they don't know how to interpret the plan. There's a time it happened to a site in the village whereby, when we are sending drawings, by mistake, the person sent that transparent tracing paper with the drawings I was sending. But the client was supposed to involve me when they are starting the site. But I think for some reason, they was like,
my guys,
why call someone all the way from Kampala to come? Now,
I think
this person got the tracing paper and went with it on site. And they used it. My friend, they mirrored the building. You see, tracing paper is transparent, so you can look at it. So they held the drawing the other way around.
Yes.
Only to reach on site now when the client started getting worried, is like, okay, now where Herman told me is the master bedroom, now it is the other side. What is happening?
Wow.
I went to site only to discover, where is the plan you're using? Come show me the drawing. The man comes with the tracing paper, only to show me the tracing paper when he was looking at it the wrong way. You get it? They had flipped it. Yet, if I wish they had involved us when they were starting. When you're setting out, your first day you're setting out, at least if you fail to do all these other things, invite someone technical. That day, you put it there, invite someone technical, they set out, they leave instructions for your people. Because it's not that we don't want to work with those people, but they need that first guidance. They need to know where the building is taking. So you really need to supervise each stage in construction, because this is a journey. You have what is done in the foundation when they are doing it. You have to supervise the heights, the quality, the sizes of the bases if they are casting columns. You get it? So then you go into the stage of casting the oversight, now doing the walls and the columns. So all these different stages, you have to make sure you supervise them. Quality work is supervised. You can't have quality work that there's no one supervising. It's only you, the client, doing everything. You're procuring, you're supervising, you're on. I've seen a case whereby one of our clients bought cement. They told him, okay, now this slab, it needs 400 bags of cement. Then I think they must have talked to the builder on the ground, like, mzee, let you baga visatu zijakola. The man brings the 300 bags. He sits on the store in the morning, sees every bag going, and the bags are not enough. And when you're casting, you don't want to stop on the way. You have to cast the entire slab. So you feel those challenges. Now you start making calls. You start calling the bank to add you some money just because you thought the person on the ground knew. So each stage is supervised with the person who is experienced. Like I said, you can have a mansion who is good at doing the brick walls, but when they are not good at casting columns, you get. For us, we know because we have our teams. I know who is good at this. So people have specialized. See your builder in your place you're building. They might be good at something and not good in the other.
That's true.
So in this team, you have to really know that, okay, now this person, he has done the wallings well. Now, if he talks about plastering, does he know plastering? Let me call my person to first see when he's starting. It doesn't take long to know that you don't know plastering. I will know. Even the way you hold the water, I will know. You get it? But the client, maybe you may not know. For us, we can look at a wall and you see it bending, and the client looks at it and says, this wall is very straight, very flat. You get it? Because we have that technical eye to see that detail. So every stage, if it is supervised, you come out with a nice project. Not that the people we use are bad, but that lack of supervision in our projects makes things look shoddy. I've seen very many sites. There's even a site I've visited recently whereby you see that the client tried to put in material, but the person on ground was not really following. They were just building to finish and go away. They were not looking at the quality. They were not looking at the what. If they had someone checking them, say, break that thing, redo it. You get it? So it is, every stage is supervised to even a level of doing the finishing, even to the last dot. So when a shell of a building is done, when you come to the plastering, how are the walls done? How is, like I told you, the gap between quality work and shoddy work is very, very small.
Very small.
And that's what clients don't know. That if someone is good in an area, if you want someone average or shoddy, of course they will charge you just a little, but you'll see that the difference would be like 2K, 5K in the amount you're paying them. Now that 5K you're saving gets you a shoddy work. You get it? But when with the right team, you can really avoid that. You can really avoid that.
Most of us thought that maybe after the setting out, engineer kumwetaga. His role is done because now he has helped you. He has come and maybe supervised the shape of your house. If he's an architect, he has helped you to, they have set out. So now the other work is just for our boys. Actually,
there's even one thing I've seen. These guys, when they say challenge, they try to eliminate it. They convince the client to eliminate it. An engineer can design a very big opening, a window on the house, and now this guy has never done it. That window needs a lintel. Maybe they have never done it. For them, they know walling. So they'll come and tell the client, you know what, this window is so big, let us make it this size. It is a design element on the house. So they will convince your client and they change the design without even your knowledge, only to come on something you did and it looks different. You get it, and it is not performing what was really meant. You get so it is it is not good to just use that local builder muzimbi wokuchalo just in some. These days construction has changed, trends have come up.
That's true.
People are building different. Building shops, they are not being done like the way Vasco da Gama design used to do it. It is now different. Houses have changed. Apartments have changed. People have learned to do nice finishing, nice material selection. So things are a bit transitioned. So, and people, they are the group that has not yet adjusted to that. So with the supervision of every stage, I think you can really bring out any project perfectly.
Let's go to now sensitive projects. We've seen now the residential projects. Now we've gone to commercial projects. Let me say schools, hospitals, hotels, projects that are 2 levels. That's ground plus 2 levels up. Yes. What is the role of a structural engineer when it comes to these slabs? We've heard of people talking of slabs. We've heard of people talking of max span slabs and, solid slabs. Who decides which type of slab should I use? Is it the structural engineer? Is it the client? Is it the architect? Or it is the consultant?
That's a very good question. And you have asked it so well. So now, let's talk about the consultant. The consultant is a name given to any person who has accumulated either a lot of knowledge or who has become an expert on something. Sometimes they call it over a period of time. Meaning that a structural engineer can be a consultant if he has acquired that knowledge and is trusted. It is not all about the age. That's what people mistake. Because it's all about what you know and what you have done on the ground. I usually tell my clients, it's not the gray hair that tells me what I've done, but I've done a lot of projects and they are standing. If I've done over 100 projects at my age and they're all standing and they're all solid, what stops me being a consultant? Should I first paint my hair gray? Or I have to first grow a big belly?
So I take a look at it.
So what happens is this. In design, especially me as a structural engineer, it's not what the client tells me. It's not what the architect tells me. Neither sometimes is it a cost. What we usually consider is the approach and the purpose of the structure. And the conditions of the designed structure that they present to us. You know, these architects, they don't want to think for us. For him, he comes and tells you, I want a slab that is cantilevered 4 meters away, you know, and he says it will be on a wall that is leaning like at an angle of 60. So now you have a scenario whereby you have got a cantilever of this caliber and the wall is this and the structure, and the architect says this is my design. The contractor absorbs that, so we find that we have nothing to do about it. So that's one of the scenarios that we find. So at that point, when you have such, we have to look for the ways the structure is stable. And what we usually do is we design each element to suit that purpose.
Yes.
There are scenarios where a solid slab is the best option to carry such. There are scenarios where a one-way slab, which is a max span slab, is okay. I've seen scenarios on the structure, which is 5 levels, where the client, for him, this time he was okay with waffles. So in my design, I had to look for the way I encompass the design of waffles. They're not even on market, but I'm a structural engineer. I had to look for the way he does that. And he had his point. He was building a school and he couldn't allow the waiting of these slabs, having that, kids are passing there. Yet when you do your structure and you put waffles, it is just 2 weeks he's done with that slab. So we usually see, what does the client want? What does the architect or what has the design recommended? And what is the viable way that is effective to make sure that it is cost effective for the client, but still it can help that structure survive. And then as a structural engineer, I take a certain route of design, then I recommend it. So basically that's what we do in design. We usually see on costs, we see on the efficiency of the structure or how it's going to operate. Then we have to also see on the loading patterns of the structure. Structures which are in areas with the earthquakes, we design them differently from areas which have no earthquakes. Structures which are tall, we design them differently from from structures which are short. Like a school, remember a school is going to carry how many people have to carry that loading and everything. We say it is going to be distributed. Hospitals are different. There's where I was designing a hospital and it has got this MRI machine. That machine makes a lot of noise. We had radiography. It emits waves which are dangerous to other people. It cannot be put in maybe pregnant women. So when designing such areas in a hospital, they are critical. We have to make sure they are solid. Have even their over 1 meter thickness solid. We make sure they are soundproof. We make sure there's a lot of consideration. Now that's a hospital. But when you go to a hotel, you are designing a hall. Maybe it is near a residence. Now this hall is having an auditorium. Then the auditorium has got a cantilever. He gave me a project of that caliber. Like very confusing. So I saw it as, even if the client wanted max spans, there's no way the structure would survive. So I had to design a solid slab to carry those loadings, to distribute them, and the project was executed and it is working. People see it, there's no vibration, and it's okay. So like the purpose and my work is to filter through my experience and see the approach I'm going to use on the structure, and every structure has got its own different approach, and that's how we approach structures so that for big projects of that caliber.
I told you this is the best duo for your site. Now you're seeing that on your site you will need the structural engineer and an architect. They all work hand in hand. Do you work hand in hand up to the end of the project, or you reach somewhere and you're like, for me, my work is done?
No, we work hand in hand until the project is done, from start to turnkey. Though different projects take different spans to get finished.
Now, because someone thinks that after these critical, situations, I think I can leave out the structural engineer or I can leave out the architect.
it's really important to have them all through, because like I told you, this is a journey. This is a journey, and the more you have these people, the more even they reduce your stress. Construction is so stressing. Most of the people get stressed when they receive all that stress directly. You imagine you're building a 5-storied building. The foreman is calling you, the material person is calling you, everyone is calling you, even the askari on site is calling you. You get it? There's a lot of stress. But now that stress has shields. And the shields are these people. They are the architects, the engineers, the what. There are things that we will not allow reach you to stress you, that we can solve. And then there are challenges that come up on site. There are some design challenges, there are some structural challenges that can happen. When you can reach on a site, you think it is dry, they dig 2 feet, water comes, streams are there. You didn't know. And that is a challenge. So if you have your structural person there, you have your architect there, it becomes easy. It becomes easy to go through. Like you were saying, there's a project we have worked on together. It's an auditorium. I wish many people could go and visit it. I was surprised when the client later on saw it and called me in a corner. I was like, you guys, I've never seen such a thing. I've been moving, but I've never seen such a thing. To them, like during the process, because of these things that go on, they had not realized how this thing is coming out. But after the plastering stage, they see the engineering, they see that solid terrace that carries people spanning all the way from the other side to down, and it is not flat, and they look at this thing as something very amazing. So to achieve all of this, we had a team, we had to collaborate, we had to bring in solution. You find that the client, his only stress is the amount of money that is going through this. These other things, they are very cleared. So, and it is something they knew that this would cost this much. You get it? So the burden becomes lighter. It becomes a bit lighter when you have a good team on your side.
When all of that is going on, what is the role of the client and what are the limits of the client? You know, when you talk of the role, someone may think that zenange solo gane mwaku magezi walieri, you know, as a client. So we want to know the role of the client and the limits. Yes. What are the limits of the client and the roles they should play on a site?
Now, the client is the final decision maker on whatever decision has been made, because they are the ones funding the project. So their main role, like the client can determine the direction the project is taking.
Yes.
They like I say, construction has to be a bit transparent. You don't want to do something and we never do something and the client doesn't know about it. It is a transparent process. So you'll always have challenges dealing with people who are not transparent. So one of the main role of the client is making that final right decision when on site. And you make that decision after making judgment of the simple research you've made. Like he was painting a scenario where the client had a friend who was advising something that was really out of what is required. And so the client had to weigh, if I go this side, the risk. If I go the right way, I have someone who is accountable. So he found that, okay, it is safe to have someone accountable for this if it goes wrong. Let me do it the way they are recommending it. So they control the direction of decision making. Then another thing, and through that, being the funders, they really determine what, they carry a big gap in determining the quality of work. Not directly, but being a final person. For example, in material can be classified even in the quality and the cost. So you find that maybe someone will say, you're recommending me to use an Italian kind of tile. Can't a local one work? Like, if it is fine with you, it can work. You get it? So they determine that. So they have like they sit in a place where to sign on the final decision. I would put it that way.
Wow. This question goes to you, engineer. There is this person who wants to build a house.
Yes.
Now, on making the plan, what normally people do even before making the plan, they have this vision, and this person wants to build a house. But before even starting to build, the first thing they ask for, how much is it going to cost me? In simple terms, they want a BOQ. On receiving this BOQ, you find that it is, it has some good amount of money, and they feel like, according to what they have, they feel like they can't afford. What advice would you give to such a person who wants to build, but now he has reached on that stage of getting the BOQ and he feels like it is too much? What should they do?
Basically, if you are going to have a vision, as I usually say, it starts with that idea, what you believe in or what you want to create, and now you put it on paper. Then what they usually give you, we call it a BOQ, which is possibly an estimate of the cost. So what I advise someone, when they put on your table a bill of quantity and it scares you, and you still want to live with that dream house, dream apartment, possibly dream arcade, don't give up before you get started. What I believe is you can face the construction, which we call phased construction. Because construction is hard, not for you alone. I've worked with millionaires, I've worked with billionaires, where they reach somewhere, they feel like giving up. Haven't you been down and you see a tall structure for one of the richest people not moving? It is for everyone. So everyone goes through that. So you have to accept the truth is, some things take time. If I might not raise 100 million now, I can raise it over 5 years. What if I keep my dream and I do a foundation for what I have now, keep doing it? In 5 years, you could be there. You can face your construction and you keep the dream moving and you give it more time. Whenever you don't have money, the issue you're fighting with is time. Maybe if you could have more time, if you could have more businesses, or if your business improves in performance, or if your source of income also increases where you're working from, possibly you can be able to deliver that. So I would advise that client, if you truly believe in that dream and you are willing to work on it, you can do it on phases. Don't be there and be scared by a total figure. At one time to be that, but after some time.
Wow. So if you're there and you're interested in construction, please check out on ArcBuild group of companies. They do construction for you, design and plan. So that's it for today. Thank you. And if you're having a question that you would want us to answer on the next episode, please leave it in the comment section. And for those of you who missed the last episode, I'll leave the link there. You will check it out, where we discussed business and finance. That's it for today. We've discussed the different roles of people on the side that is starting. And I think you've really learned something new. Yes, me, I didn't know that not everyone on the site is an engineer, which we all think. So, thank you very much. That is the Engineer's Corner podcast for you. We do engineering, business, and inspiration.